My name is Andrew, and I'm really excited to show off Airtable ML, a machine learning library that I've been writing for Airtable. Airtable ML trains a neural network in your browser and is GPU accelerated. It will classify and regress on many different types of Airtable fields and is very open-ended, so you can use it to predict numbers, categories, dates, currency values, and more. And I'm really excited to see what people do with it because I think that it will be useful for automatic prediction and classification for things like sales projections and regression for numerical analysis, and probably a lot of other uses that I haven't thought of yet. It's completely open source, and I'm going to walk through how you would use it on a couple example tables. So let's look at an example on some sales training data. So this is some data, some hypothetical data for some sales with projections, the sales stage, a predicted probability of closing. This was manually entered by humans based on their best guess of the probability of this deal closing at the current time. And we're going to learn a prediction model that tries to estimate closing probability based on this training data that can then be used for new data where a human doesn't have to estimate this probability by hand. So first, you install the Airtable ML block, and then you go to its settings. You tell it which table you would like to train on. Then you tell it which field it's going to be learning from. And it only shows you fields that it is capable of analyzing. So we'll tell it the probability field, that this is the field that's been estimated by humans already. Then you tell it which field you'd like it to fill in, which is the probability prediction field, and this needs to be of the same type as the field that it's learning from. Then you tell it which columns it can use. And you should be careful to avoid columns that are full text data because it can't currently learn from those. It can learn from short text fields. So for example, if you have a text field that is just only takes a couple values, it can learn from that, although that probably would be simpler as a single select field, but either one would be fine. But free-form text fields aren't currently usable and will make it very slow to train. So you pick the columns that you think it would be useful for it to learn from. And this uses your intuition as a human. So for example, the name of the sales deal probably isn't relevant, but who the rep is probably interesting. The priority, the estimated close date seems very useful. The forecasted value and the last contact all seem useful. So we'll add those, as well as the current stage seems very relevant. So we'll add that as well. Next, you set up the neural network and you can leave the defaults. It will try to guess the right number of hidden layers based on your inputs and outputs. But you're also welcome to tweak these values, including selecting different activation functions, learning rates, number of iterations you may end up changing, and more. So I'm going to leave the defaults initially. And then I'm going to train this neural network. And this may take a little while. You can see the error rate versus iteration. And in general, you're waiting for the error rate to fall, and then right when it starts to climb, again, is probably a good place to stop. So we're going to let this train, and the default number of iterations is probably going to be about right here. But sometimes you may need more if you have a lot of training data. So I'm just going to let it go to the default, but you may end up wanting to tweak this. And then next, we're all good. So now we go back, we leave our settings, and now we're in the normal block mode where it can add predictions for this table. So it will fill in values for its prediction column that are empty. So if we click to generate predictions, it will go through and fill them out. And you can see here that some of them are wrong. For example, this probability we estimated at 80% and it thinks it's only 40%. But many of them are pretty close to what you would expect. 90%, 90%. These are all pretty close. And if you find that it's not doing well, like here, this is 70%, but here, this one definitely wrong, or disagrees, it's possible that the human's estimate was wrong. If you find that it's not doing well, it's likely that you want to add more training data. And this is almost certainly nowhere near enough data to train a neural network. This is only 22 rows. So let's look at another example where I think it will do better. And this is a classic example for machine learning. The iris dataset is a dataset of iris flowers, and we're trying to predict the species. So I've previously run this, and so I'm going to clear out this existing predictions so that I can retrain a neural network. So I'm going to go over here, I'm going to train on the iris data set. My prediction field, my training field is species. My prediction field is the prediction for species. Again, they're of the same type. This time they're just a text field. I am going to use all columns except for the actual correct answer. I'm going to use the defaults again, and I'm going to train a neural network. This time it's slower because we have quite a bit more training data. And I'm going to let this run. And I actually went ahead and stopped the training because I could see that my error rate was quite low and had stabilized, and I didn't seem to be making any forward progress. So I stopped the training, and I went back to the block, and then I'm going to generate predictions. This may take slightly longer because there are many more columns here. So here we can scroll through, and we can see that it is correctly classifying basically everything. Here's one error, but in general, it has done very well. I only saw a couple errors there. So here the neural network has learned to predict this classic example from the machine learning literature. Finally, another example. I'm actually not going to train on this one because it's too little data, but I think it would be a good example. I think with more data, this would be a very interesting classification model to learn. This would be projecting the predicted completion date of a bunch of projects in the backlog of an engineering team. So this is the end of my tour of Airtable ML. I hope it was interesting. I'm really excited to see what people do with this. I think it could be really powerful. As with all machine learning challenges, the real problem is in generating your training data. I think for this block to be useful, you probably need to give it a couple hundred labeled examples. And then once it's learned off those examples, you can start giving it unlabeled examples that it can predict for you. There's a couple areas where I would love additional contributions if someone would like to join me in this project. One is in doing cross-validation so that we can get a better estimate of how the model does on unknown data as opposed to on its training data where it may be overfitting. In the same direction, it would be great to have confusion matrices that show us the number of correct and incorrect labelings that it has performed. And it would also be very interesting to extend this to provide interpretable models such as decision trees, or to work with freeform text using the LSTM models that are already available in Brain.js. So thank you for your time.